The area of a parallelogram is essentially the area of a rectangle with the same length and the same height perpendicular to that length. So this is your parallelogram. Then you know that this is your length and that your height is the perpendicular line, sometimes called the altitude for a triangle. And you know this is true because let's say this height that you've created, you just take scissors and you cut that piece and then you put it here. Then you have a rectangle, which you would know is just height times length. And you can do this with any parallelogram. If it's just barely a parallelogram, still take that piece, put it here. If it's extremely skewed, take the piece, put it here, and it's still a rectangle. So no matter what, for any parallelogram, you just need to know the height and the length. And if you don't know the height, but you know the angle, then you would just do length times this side sine theta, and you'd get the height again. So, final thing is that this principle even applies to volumes. So if you have a prism of any shape, let's say you have a hexagonal prism, and if you knew the area of the hexagon, you knew the height, then you could find the volume of this prism. And then even if you had it skewed, you still just needed to know this apparent height and the area, and it'd be the same value.